Welcome to homework.
So in the first part, we have to find the equivalent resistance between points F and H. So as you can see, uh, between points F and H, so we see that this combination of two resistors and this R and these two resistors are in parallel because they have the same voltage difference. So let's start by finding the equivalent resistance of this component, just the upper part. So this R and this R, these two are in series because uh, the current is flowing in the same direction and is not getting divided. So the equivalent resistance of that part, so let's call that R1. So that will be equal to twice of R, hence 10 ohms. And R2, which is just the middle part, is 5 ohms. And similarly R3, the bottom two resistors are also in series, so they add up to give an equivalent resistance of 10 ohms. Now R1, R2 and R3, that is this combination, this one, middle one, and this one. So these three are in parallel with respect to these 2 points F and H. So we can use the inverse addition rule in order to find the equivalent resistance. So 1 over R equivalent for points between points F and H will be equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now plugging these three values over here and solving for R equivalent, we find the equivalent resistance to be equal to 2.5 ohms. Now for part B, we have to find the equivalent resistance between points F and G. So again, let's see what are the resistors that are connected in parallel with respect to these 2 points. So here we have these two parallel with respect to F and H. So R1, let's call this R1, so that is obviously 10 ohms, R plus R. Then R2 is equal to 5 ohms. Now this combination, this one and this one, these two are in parallel obviously because they have the same voltage difference. Oops. Yeah. So we can find the equivalent resistance of this part by adding the inverse and then adding the reciprocals of the resistance and then taking the inverse. So this will give R12 to be equal to 5 times 10 over 5 plus 10, and the units is in ohms. Now this whole combination, now that we have the equivalent resistance of this combination, so this is now in series with this R. So the equivalent resistance of that, so let's call that R1 to R. So that is this factor plus R. Now the one that we found R1 to R is this part. And with respect to these 2 points, we can say that this whole combination is in parallel with R. So the total equivalent resistance will be equal to R times R1 to R, which is the parallel equivalent resistance of this part, over R plus R1 to R. Plugging the other variables, so we plug R1 to R in terms of R12 and R, and again we can substitute this expression over here and solve for R equivalent, and that gives us the equivalent resistance of between points F and G to be equal to 3.13 ohms. So I'll just let you know what the calculation of R1 to R will be. So R1 to R should be equal to 8.33 ohms, and this is what the equivalent resistance between points F and G should look like. Thank you.